Hi everyone. In this video, I want to talk about Lab 1 for ENGG225 and basically give an idea of how to get started with it. So first, you have a kit. So let's look at what's in the kit. You have a digital multimeter. You have a bunch of resistors given in a plastic bag, and there are many different resistances in here. How to determine these resistances, you can do it from color coding, the color coding here, or you can just use the multimeter to measure its resistance. For the color coding, you can use what you have in your introduction PDF of the labs. At the final page, if you look at it, you'll have this color coding there. Okay, so we have a bunch of wires. Okay, here we have two DC-DC converters. This we're going to use a lot. It converts 5 volts DC to plus minus 15 volts, and we're going to use these a lot. We have capacitors in here, pin header, LEDs, and okay, so this one we're going to use a lot in Lab 3. This is an IC op amp, and you're given 5 of these because sometimes they break. And yeah, what else? We have a potentiometer here. Yeah, and a push button. Okay. And so this is a breadboard, and this is a battery holder. Okay, and it has an on-off switch. And you're given 4 rechargeable batteries. So yeah, this is make sure that you only use rechargeable batteries because of the voltage difference, and not to use non-rechargeable batteries in here. And because non-rechargeable batteries, they might actually exceed the input voltage rating of the DC-DC converter, which is 5.5 volts, and damage that. So always make sure to use these rechargeable batteries. Yeah. Okay. Let's look at what's inside here. Okay, so we have 2 batteries. This is the digital multimeter. And this is the probe of the battery. Okay, later on you'll see that this is too big to go in here, so we'll have to think of some ways of measuring actually the voltages or currents. But for now, so this is right now not turned off because the batteries are not inside. So you have to put the batteries inside. To do that, take this off, and it's here. You have to use a screwdriver to open this up. Yeah. Put that back in, and it's right now, it's actually turning on. How do we use this multimeter? We can use it to measure voltage, current, and the resistance, and we'll show it later on how we do that. Okay, so let's get started with the lab. Next, we're gonna explain the breadboard. Um, so here's the breadboard, and what it is basically is that it consists of two types of connections. So there's a type 1. So let's look at the type 1. Type 1 is basically consists of parallel rows of 5 horizontally connected holes. So if you look here in each, here we have row 1, hole A, B, C, D, E. So all these 5 holes are connected to each other. Same in row 1, but it's separate from row 1 is separate from row 2. You can see this from this shaded area here. If I zoom, so these ones are connected to each other, but they're separated from the next row. So if you can see here, we have about 64 rows, and in each row, holes A, B, C, D, E are connected to each other, and these are type 1. And you have a separation here, and then you have another set of exactly type 1 socket strips again. On this side, FGHIJ, which these guys are, these holes are also connected to each other, and we have 64 rows of them. So you can see this here. So this separation here is basically for ICs, which we're going to use in lab 3. So you have this op-amp IC, and this actually very easily settles in here. Okay, so you have each of these legs connected to these strips. So you can use these holes here to connect other elements to this IC. We're going to look at this in lab 3. Okay, so and there's another one which is the type 2 circuit, and in type 2 holes are connected vertically, and you can see the type 2 circuits on the very right and the very left side of the breadboard. So you have, as you can see here, the node and the holes are connected together vertically, and so everything under minus is connected to each other, and everything under plus here is also connected to each other. Same goes on the left side. Everything on the minus is connected, and everything on the plus is connected to each other. But they're separated. The minus and the positive are separated from each other. Okay, so next let's find the 5 volts, and let's create a 5 volts across this type 2 socket strip on the right. So I want to have a 5 volt difference between the minus and the positive of this type 2 socket strip. To do that, we can use the battery holder and the batteries. Okay, so you're given 4 rechargeable batteries, and make sure to only use the rechargeable batteries because of their voltage. If you use non-rechargeable, it could damage the DC-DC converter. So always make sure to use the rechargeable batteries that you are given. And another thing is that, so it's if you short two batteries, that means that if you put these batteries inside this battery holder and you accidentally, or when you're making the connections on your breadboard, you somehow short circuit these two wires, the red and the black wire. So that would mean if these batteries are inside here, so that you are short circuiting the positive and negative terminals of these batteries, and high current can pass through these batteries, and it can cause them to heat up, burn, or even explode. So it could be dangerous, hazardous. So watch out for that. Always make sure that your connections, and that these two wires, the red and the black, are not connected in any ways through the circuit. And always make sure not to, so whenever you want to leave your setup, take the voltage out of the battery holder so that whenever the base take the batteries out of the battery holder, basically whenever you have the batteries inside the battery holder, you have to be present there. If you want to walk away, or if you're basically done with the lab, take the batteries outside of the battery holder, and always make sure that these two connections are not connected in any ways to each other. So when you make the connections, make sure that they're not connected through the circuit to each other, and then put the batteries inside. Okay, so that's really important safety issue. Okay, so now I want to create the 5 volts across this type 2 circuit strip. So I'm gonna connect the negative one, the vertical holes to the very right to the black wire, and the positive type 2 circuit strip to the red wire. Okay, so now here you can see that there are no connections between these two circuit strips, right? So there are no connections between these two. I'm sure that these two are not connected through the circuit. Very important to make sure of that. So if this was in a type 1, like in between here, these two, if it was in a row, these nodes would be connected. I can't connect these two wires like on these two holes, for example. But I can connect them between these two type 2 circuit strips, because type 2 circuit strips are connected, the holes are connected to each other vertically. So now that I made sure of that, I put in the rechargeable batteries inside. Okay, and it's a bit of a okay. Oops, this came out. Okay, so your batteries also have an on-off switch here. So if I'm sure that these two are not connected. If I turn this on, that means right now I have this 5 volt across this between these two nodes, or type 2 circuit strips. So how can I know that? I can measure it using the digital multimeter. So the digital multimeter here, if you see on the right, you have a capital V and a line to the right of it. That means this portion of the multimeter measures the DC voltage. And then here you would have the voltage and the AC, which is shown by the sinusoidal shape. So you can measure AC voltage here. In this portion to the bottom, you have A to the, and then you have a line here. So that means this portion measures the current. And on the left side, you have the measurement of the resistance. And here, this one right here is to measure, to see if 2 points are short-circuited, which we're going to show in a bit here. 2 nodes. And so in order to measure the voltage, we're going to use a range between here, which we're going to show later on. But for now, let's see the probes. Okay, so these are the probes. So you take these leads out. Whenever you want to measure voltage, or you want to measure a short circuit or resistance, so voltage, short circuit, or resistance, you connect the black one to the middle and the red probe to the right one, like this. Okay, so this is how you set it up. Now I just want to measure my voltage. So how to measure your voltage? If you can see here, there's 200 millivolts to 1000 millivolts, which is 2 volts, 20 volts. And what we know we're measuring is 5 volts. So it's between this range. So it's above 2 volts, but below 20. So 20 volts will show that 5 volts to us. But The problem is that these holes are too small for these probes, so these can't go in. Okay. Okay, so now we have to think of a way to measure the voltage across this. One method that I think would make things much easier throughout the whole labs would be to take two of these long wires, one black and one red, and basically cut one end off. So as you can see, I got one of these long wires. I cut the one end off, and then use the wire stripper to take to get this wire out. Okay, so something like this. All right, and I did the same thing with a black wire. So you have two wires, and then one end has these, and then the other end you take the wires actually out. So you cut the ends, and then you use a wire stripper. So the idea is that these ends can easily go into the breadboard, and if we can somehow connect the other end to the probe, measurements would be much easier for all the labs. So how I do this is with electrical tape. So I wrap this wire around this, and then I use electrical tape. If you have some at home, to just wrap this around it. Make sure that the end point of this is connected to the tip of the probe. Then I'll do the same thing with the black wire connecting it to the to this end of the tip. And okay. So now we have to test that these ends are properly connected to the tip, so that this is actually connected to this tip here, and this tip is actually connected to this tip here. It's securely connected. So to do that, we'll go to this beep right here, and so make sure it's not on shift. You didn't hold press the select. So you go here, and you just, if you hear a beep when you connect these two, that means these two, there's a short circuit between these two, and that's what we want. Okay, so this is good. So these ends are connected to each other securely. So now if I go back to my 20 volts, right? So now I want to make the measurements. So now these points could not go in here, but these points here can go easily in the breadboard, right? So if I connect this here, and if I connect this here, I'll get, okay, so if you remember, we had an on-off switch. So whenever I'm working with the board, I always turn this off, so my board is not energized at all. So the battery is turned off basically, so there's no voltage. And so turn this on, and oh, okay, so this came out. I'll put this back in, and yeah, so we get 5.2 volts, which means that these four batteries that are in series create 5.2 volts, and each one of them is creating about 1.3 volts. Yeah, okay. So if you do this once and you have this set up, the measurements for currents, resistances, voltages, everything would be much easier going forward into the labs. Okay, so now that we know we have this 5 volts here, turn this off because we want to work with this board now. take this measurement off. Okay, now next we create the 15 volts, creating the 15 volts. So we made the 5 volts on the right side, and now I want to create the 15 volts on the left side. So make sure that you turn off your battery so that circuit is not energized. Okay, so how do we do that? We use the DC-DC converter here. Okay, so this is the DC-DC converter, and now let's connect it like this, what we have in this graph here. So this top one, connect this to row 1, like so. And then we have to make the connections of the 5 volts, which is here, to pins 1 and 2, all right? So if you see here, the yellow wire, which is here in yellow, also yellow and yellow, is connected to the positive node, right? So 1 is connected to the positive, and then the green is connected to node 2. So the green, it comes from the negative of the -5, the negative of -5, which is this green wire here, and it's connected to row 2 here. Okay, so let me get a green. Okay, use a small green one. And okay, and then so now my 5 volts is connected across pin 1 and 2, where pin 1 is connected to the positive. And now from pin 4, which is on row 4, I can get the positive voltage out. So right now I want to get only a positive voltage of 15 volts here. I don't care about the negative 15 volts. So I'm going to connect pin 5 and pin 6 to the left socket strip type 2 here. So I want to create the 15 volts here. What I do is that, as shown in here, so pin 5, so I'll find pin 5 is on row 5, and row 5, if you remember, all the FGHIJ holes in row 5 are connected to each other. So I'm going to use this node here, and then connect it to pin 5, connected to the negative terminal of the 15 volts. So the negative terminal is here, right? So here, 5 and 6, when I give 5 volts to 1 and 2, I'll get 15 volts across 5 and 6. And I want to connect this 15 volts across pins 5 and 6 to my strip here, so that the 15 volts runs through along all these two vertical lines. So now the 6 is, I'll take a red wire, connect the pin 6, which is on row 6. Again, we can use any holes FGHI, so I'm going to use this one right here. So pin 6. To the positive of the type 2 socket strip, right? Okay, so now if I turn this on, I'm giving 5 volts to pin 1 and 2, and the output of this DC-DC converter is a positive and negative 15 volts, which for this lab, I'm only going to use the positive 15 volts. How do I do that? I connect the positive, I connect pin, the leg 5, which is connected to row 5 holes FGHIJ. I can use any of those holes and then connect that to this type 2 socket strip on the left, the negative terminal. and then I connect the other end, the red wire, to from row 6 to the positive of socket strip here. So here I give 5 volts, 5 volts goes in, 15 volts comes out, and then all the 15 volts I can see here. So now let's see if we actually energize the circuit, do we get the 15 volts? So I'll put this here, I'll put this in, and then turn this on. So yeah, as you can see, we got 16 volts. There's a bit of error. So 16 volts, 15 volts, 14 volts, between these range is completely fine. So we actually got the 16 volts as we wanted. So I connected so because the 15 volts was again between 2 volts and 20 volts, I didn't change this part here. And because I was measuring the voltage, nothing changed. I just basically connected these two ends. I was measuring these two socket strips first, which was 5 volts. Now I'm measuring here, which is about 16 volts. So now that we have the 5 volts and 15 volts, we can go and actually do the start these connections of the resistors and make more measurements. So make sure to switch the battery holder off again, because you want to perform some work right now on the breadboard. So make sure to take this to put this off. Now, okay, so we created the 15 volts. Now we want to do the measurements. Okay, so we have to create this circuit. We have the 15 volts, right? So the 15 volts is across this minus and positive terminal of these two vertical wires, right? So any of these 2 points would be which are parallel to each other vertically. Will be 15 volts. We can get the 15 volts, and then we have to connect it across 4 1K resistance. All right. Okay. So now let's make this. So we have to find the 1K resistances. So how you do this again? So you just basically read the colors, and then these colors, the instructions of how to read them is the introduction lab, and in the last page you can find that. So basically you find the 1K, and so you connect them such that these 1Ks, the end of one is connected to the end of another one. Right, so we need 4 of them. Okay, so going back to how connections were made on the breadboard. So I want to use the type 1 socket strip in order to make that series connection of resistances. Okay, so I'll connect this to one node here and then another node of connection, right? So I connect one end to row 35 here, and then another end to row 40. Okay, so now I want to make another series connection, right? So I make sure that this leg is connected to row 40, but this leg is row 40, column B. Now I connected to column A, C, D, or E, because all these nodes will be connected on the same row, right? So there's a connection between these nodes, these two legs here, okay, which is what we want. So I'm going to connect it to C, and then do the same thing for the other two resistances. So when you're doing the labs, make sure to, I don't know how you want to do the presentations, but if you're, for example, doing a PowerPoint, which where at the end you're going to put your voice on top of it and record it and upload it, you can just take pictures along the way showing that, for example, you made this when you had the 15 volts, you can take pictures with everything on it and then put it as a slide and then explain it, what you were doing. And there are some questions that we'll get to that you have to be doing those as well and showing that, for example, those measurements, taking pictures of those measurements, which we're going to get to. Okay, so we have four series resistance here, and now I want to create 15 volts here across this, connect 15 volts to these four resistances, right? So I'll take a black wire and a red wire. And okay, so now I want to connect these 15 across these four resistances. So I connect, so this end, so I know that this end is connected to row 35B, so, and it's connected to all the other holes in row 35, which is A, C, D, or E, right? So I'm going to connect this to A, and then the red would be connected to actually what was the positive terminal, right? So I'm going to connect it to the very right side vertical line. Okay, and the bottom node Z, so basically this is node X here. And node Z, the black wire, is going to be connected similarly, but to the negative terminal of the minus 15 volts. Okay, so I should have positive and negative terminals here. And if I turn this on, I'll have this 15 volts across these four resistances. Okay, so now we have this set up, and then what do we need to do? We need to perform some voltage, resistance, and current measurements. Okay, so let's start with the voltage measurement. So we need some VXZ. So make sure to read these actually completely and actually know what to record. So record both these voltages, for example, and how are they similar or different. So we have to measure voltage VXZ, but read exactly what you need to do and perform it. So we might actually miss some of them here. It's just showing you how to do the labs, not exactly every step of the way. So make sure to actually go through this and know what you need to measure, what you need to discuss about. Okay, here, for example, we have VXZ, VZX. So we want to make the voltage across these two, right? Yeah, so actually we want to make the measurement across 15 volts the way we did it here, but now we want to have it across the resistance. So before we did the measurement across the type 2 socket strip. Now it's not different really, but we're just going to make the measurements on the type 1 socket strip. So I'm going to connect these probes across the resistances here. It's not different. I should again get that same 16 volts when I turn this on, right? Okay, so you have this connection here. Now, before you turn this on, make sure that this is on that 20 volts so that because you know that you are measuring the 15 volts, right? So now when I turn this on, this should go to 15 volts. Or that's 16 volts. Okay, so we get the 16 volts, 15.93 here, which is what expected. Okay, so now then the question asks you to measure the VZX. So you basically have to flip this. So the positive will be connected to Z and then X, and then you do the measurement again. And you record it. Record both these voltages. How are they similar or different? Okay, so you have to do these and then now perform two different resistance measurements. Okay, so now we want to perform resistance measurements. One very important thing when we're doing resistance measurements, so let's take this off, is this. So remember, the resistance measurements should be made only on non-energized circuits. So you have to always make sure that this is turned off. To be actually more certain, maybe even take this out, so make sure that there's no energy flowing through your circuit when you're measuring resistances. Okay, how do we measure the resistances? Here we need, for example, reverse the DMM. With the DMM connected to node X and Z, measure and record the total series resistance of the circuit. So we want to connect the the probes to nodes X and Z, and then actually, and this 15 volts right now is turned off, right? So because there's no, so to measure the resistance across this total resistance, how do we do that? So if you remember, the resistance is on the left side here. So this left side is the resistance, and you have, like the voltage, you have different levels. So you have 200 ohms, 2000 ohms, which is 2K, and then 20K. We know that the series of series resistances of 1K is 4K. So our resistance is going to be between 2K and 20K. So I'm going to put it on 20K to actually be able to measure that. And next, I connect this to node Z. So I connect the black wire to node Z and then the red wire to node X. And I have about 3.85 with the error. So that's about 4K, but with some error, right? And you have to explain. So these errors, you can actually see it from these color codings here. So this is actually, so one of the measurements we did here. So next it asks you just to measure the reverse, so if measure actually reverse the DMM's connection to node Z and X. Does this value of resistance change? So basically connect the red wire to node Z and then the black wire to node X, and then measure them all again, and the resistance again, and see if there's any difference. How are they similar or different? You have to explain these. As I said, this is just basically showing you guys an introduction of how to do it. We're not going to go through all the actual details, so please read this part carefully and answer the questions and provide everything in your presentation. Now perform two different resistances. Okay, so we did this. Okay, now it says to place a short circuit in parallel with the lowermost resistance in figure 9 and measure and record the total resistance again. So here we're going to make a short circuit between this resistance here. How do we do that? I take a wire. So I'll take this blue wire here. Okay, and I want to connect it between Z and Y, right? So Z and Y is this resistance here. And I'm going to connect, so a short circuit, basically a wire between these two nodes, right? And then connect the why do this? Okay, here. Again, measure and record the total resistance. So now again, we want to measure and record the total resistance. Obviously, the total resistance should drop, right? Because basically we're shorting out this resistance, so your total resistance is expected to drop. So if you do this, so it's about 3K right now. Showing a bit of variation. All right, let's put it here. Okay, yeah, so if you put it down, so it's 2.92 kilo ohms when you put it on the 20K. So this is 2.92 kilo ohms. And it's right, because when you short circuit this and you have basically you have three resistors in series, which is 3 kilo ohms, which is what you get here. Okay, now after the resistance, we want to do some current measurements. Okay, make sure the switch is off. Now remove the short circuit that we did with this blue wire, and then basically we have to create this figure 10a here. We want to know the current going through the entire circuit. Okay, so it's really important. So this is actually a warning that there's always a risk of connecting an ammeter. Basically, when your multimeter is acting as an ammeter and measuring current, so there's a risk of connecting the ammeter incorrectly, resulting possibly in high currents, overheated components, and blown fuses. So please double check your work and or triple check your work when you're doing this part. So now let's create an ammeter here. So the positive terminal, I want to connect to the positive 15 volts, and then the negative terminal to the negative 15 volts. First of all, when we're measuring this, I know that the 15 volts across the 4K is going to be in milliamperes, okay? And so if you look at here, so the red one in here, it says V milliamperes microamperes. So as long as we're in the milliampere or microamperes, the red socket is kept at this point. So I'm gonna remove these two ones from the voltage. So right now I know that I'm gonna be in about 20 milliamperes, and it's a DC current. And in this, it says the milliamperes, so the red should be here. And if you're going to 10 amperes, something like that, your wire should go to the left side. But right now, we'll keep it the same as what we had before. Okay, so here, as we had in the measurement of the voltage and current. So this is the setup. Now, I want to connect this. So the positive, so what I have to do is that I have to break my connection from the positive node to node X, right? So this was node X, right? And the connection between the positive node and node X, right? So I have to break this. So I take this out. Now I have to connect the positive terminal of my ammeter right now, this positive, to the positive of 15 volts. So the 15 volts was here, so I'm going to connect this to here. And then the negative terminal of the ammeter to node X. Node X was this resistor on row 35. Right, so now I have these connected. Okay, and this on 20. So I'll double check that, okay, so my ammeter is here, and then the red is connected to 15. I took out my connection between 15 and X, that's good. Now I connected the negative probe to node X, that's good. All right, everything's good. And so now I can connect my wires, the 5 volts. I'll also be very careful not to short circuit this. Always put care, don't just try to see how it goes. If it's giving the right answers, double check, triple check, make sure every connection is correct, and then power up. So now this is off, and so we can turn it on. So before we turn it on, I want to see what happens. So what's going on here is that the positive, so positive 15 volts current will come here in and then go inside the DMM and out to the resistance. So the current will come from the voltage 15 volts here. The current will comes into the ammeter and then goes out through the black wire to node X to the resistances, and then comes back to negative 15 or ground here. Right, so let's turn this on. Okay, so as you can see, this is about 4.05 milliamps. And yeah, this is it for this part. And there are some other things that is asked from you in the question, so please go ahead and read and answer those. And there are some comparisons that you have to discuss about here. And the next part for the current, we want to connect the DMM or the ammeter across Y and Z here. So last time we just short circuited this in the voltage measurement, in the resistance measurements, if you remember. Now I want to put an ammeter here. Okay, so again, I turn this off. So there's no, I want to work with my circuit, right? So I turn this off so my circuit is not energized. Now I take this out, and the probes basically, and I see that now my 15 volts is again connected to node X. So okay, I take this, node X was row 35, I connect this to the 15 volts, so this is back. And now I have to connect the positive to node Y. Node Y is here. In my circuit, it's row 50. And then the negative terminal to node Z. Node Z is row 55 here. Okay, so now it's properly set up. So I have my positive 15 volts connected to my node X with this red wire here, and my and the red probe, which is the positive ammeter, is connected to node Y. Node Y is this connection between the bottom two resistances, and then the negative terminal is connected to node Z. Okay, and then I power up again. And so I see that it's 5, it's a bit higher. And so make sure to take measurements and pictures. And yeah, and then there's some explanation that you need to do, and then some comparisons. And that's basically it for this lab. So now make sure, turn this off, make sure that you turn this off, take these two wires out, and very important this part, guys, take the batteries out when you're done with the lab, okay? So that these 2 points don't short circuit accidentally and then cause some hazard. So make sure to take the batteries out at the end of your labs. Yeah, thank you very much.